Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video we'll discuss about question number 30, NEET Physics paper 2016. Question number 30. It says a long straight wire of radius A is a long straight wire, very long straight wire, and it goes up to infinity. So the radius is A is the radius, carries a current I. Suppose the current that is flowing is I. The current is uniformly distributed over its cross section. So over its cross section, the current is uniformly distributed in this cross section. The ratio of magnetic fields B and B dash at a radial distance A by 2 and 2A respectively. A by 2. So what are those two positions? One position is the half the radius, that is A by 2, somewhere here. This distance is A by 2, and at this point the magnetic field is B, and at a distance of 2A, suppose this is 2A, the distance is 2A, magnetic field is B dash. Our aim is to find the ratio of B over B dash. This is our M. Now the formula for magnetic field due to a straight conductor carrying current I is given by, at a distance x, is given by B equals to mu naught upon 4 pi 2I divided by x. This is the formula used. This is going up to infinity on both sides. Now this is extending up to infinity. This is also going to infinity. Our aim is to find B at a point which is at a distance A from the axis, A by 2. So using this formula, the B formula for the point A by 2 distance from the axis, this is mu 0 upon 4 pi 2 for interior point. This point is lying inside, and for inside point it is 2I divided by x. X is your A by 2 because this point is at a distance A by 2, and this is A is the radius. This is smaller. It is A by 2 here, because for the interior point I have not written. Okay, let me write for the interior point. For any interior point, the formula for interior point or inside point, and this is the formula for outside point. Inside point is mu naught upon 4 pi, mu naught upon 4 pi 2I small r over r square, where small r is the distance of the point where you have to find the value. So this respect, this will be A by 2, r is A by 2, and this is r square. R is the radius of the conductor, which is A square. So it is not 2, it is square of this. So if you solve this, it will get mu naught upon 4 pi 2I A by 2 divided by A square. This is equation 1. Now for the point B dash, that is for the point lying at a distance 2A, where A is the radius and the current is uniformly distributed over the cross section. The magnetic field here is mu naught upon 4 pi 2I by x. X is 2A. This is the formula used. This is equation number 2. If I divide 1 by 2, we will get B over B dash equals to mu naught upon 4 pi 2I A by 2 divided by r square, that is A square, divided by mu naught upon 4 pi, this value 2I over 2A. If I solve this, then this mu naught upon 4 will cancel, 2y will cancel, this will become a by 2 and a square is there. Here it is 1 upon 2a, so 2 will come up. This is 2a square, here also 2a square, so the ratio is 1:1, so we cancel out 1:1. So that means the answer is 1. Option number 4 is the correct answer because that is 1. So this is the right answer to this question. Okay, thank you.